Every time we think we understand the universe, it quietly does something illegal. What James Webb just saw is bigger than the Milky Way's oldest memories, brighter than it has any right to be, and sitting in a place where by every rule we trusted it should not exist. We're talking about galaxies already grown up when the universe was still a newborn, shining when cosmic darkness should have been winning. This isn't a small discrepancy. This is the universe showing us a finished city where there should only be scaffolding, and once you see it, you can't unsee what it implies something fundamental about cosmic history may have been rushing far faster than we ever allowed ourselves to imagine. We need to reset our intuition before we go any further. When we look up, we are not looking across space, we are looking backward through time. Light is slow enough that distance becomes memory. The farther we look, the younger the universe becomes. At extreme distances, we aren't seeing galaxies as they are. We're seeing them as they were, billions of years ago, before Earth existed, before the sun ignited, before atoms had finished deciding what they wanted to be. But there have always been limits. Dust hides. Space stretches light until it slips out of human vision. For centuries, the universe protected its earliest chapters behind these barriers. We built telescopes that could sharpen stars, count galaxies, map collisions, but the beginning stayed blurred, unreachable, theoretical. Then, on Christmas Day 2021, we launched a machine designed not to look farther but to look earlier. James Webb doesn't see what your eyes see. It sees heat. It sees stretched ancient light that has been travelling since before galaxies learned their own shapes. Infrared is its language, and infrared is how the universe whispers its oldest secrets. Webb doesn't just collect images, it intercepts messages that have been en route for over 13 billion years. And almost immediately, something went wrong. We expected the early universe to be simple, chaotic, yes, but small. The prevailing story was clear after the Big Bang. Matter clumped slowly, gravity worked patiently. The first stars flickered on. Tiny galaxies assembled piece by piece, dim and fragile. Over hundreds of millions of years, large, mature galaxies were supposed to come much later after long epochs of trial, failure, and collapse. That story made sense. It was comfortable. It fit our equations. Webb didn't read the script. As it stared deeper into cosmic time, it started finding galaxies that were already massive, already bright, already structured when the universe was only a few 100 million years old. Not toddlers, adults. Galaxies with too many stars, too much mass, too much order, too soon. One of them, confirmed through its stretched light signature, sits at a redshift so extreme that we are seeing it as it existed roughly 300 million years after the Big Bang. Pause there. 300 million years. That's not even 3% of the universe's current age. In cosmic terms, that's infancy. And yet this galaxy is luminous enough to stand out across the abyss, chemically complex enough to suggest generations of stars have already lived and died, and physically large enough to violate expectations baked into decades of cosmology. This is the moment where scale matters more than numbers. Imagine the universe as a city under construction. According to everything we believed, at this stage you should see empty lots, scattered foundations, maybe a few wooden frames. What Webb found instead was a skyline, lights on, infrastructure humming, history already written into the walls. And this wasn't a one-off glitch. As data accumulated, hundreds of programs, hundreds of terabytes patterns emerged. Multiple early galaxies showing the same unsettling maturity. Too many stars forming too fast. Too much mass assembled too efficiently. The early universe wasn't stumbling forward. It was sprinting. We're forced to confront a brutal possibility. Either our models are missing something profound, or the universe found a shortcut we didn't know existed. Now bring yourself into this. If you were somehow placed near one of these galaxies, if you could survive the radiation, the chaos, the raw youth of everything, you wouldn't see a calm spiral like the Milky Way. You'd see intense star formation ripping through gas clouds, Supernovae detonating in rapid succession, heavy elements forging themselves at impossible speed. This is not a quiet dawn. This is a violent birth accelerated beyond schedule. And yet, it worked. That's the unsettling part. The universe didn't just try this, it succeeded. Which raises the question we can't avoid: how? One answer whispers from the darkest corner of physics. Dark matter, the invisible scaffolding that outweighs normal matter, 5-1 may not have been a passive bystander. Some models suggest that in the early universe, dark matter could have concentrated so densely that it powered the first stars themselves, not by fusion, but by annihilation. Hypothetical dark stars, enormous and long-lived, could have flooded space with infrared light, kick-starting galaxy growth at a pace we never anticipated. If that sounds extreme, it should. Because the universe we are now glimpsing is extreme. Webb didn't set out to break cosmology, it set out to test it, and in doing so, it may have revealed that the early universe was far more efficient, far more aggressive, and far more creative than our clean narratives allowed. We're still here. We still matter. These galaxies are not denying our place, they are contextualizing it. Every atom in your body required generations of stars to live and die. Webb is showing us that the universe wasted no time getting started on that process. And this is only the opening crack. Because if galaxies like this existed so early, then everything downstream planet formation, chemical enrichment, even the potential for life may have had a head start we never imagined. The universe didn't wait. It rushed. And as we continue forward, deeper into this story, the question is no longer whether something shouldn't exist. It's how much more of the impossible has been hiding just beyond the edge of what we thought was allowed. Sources. We tend to imagine beginnings as fragile. We picture the early universe as a dim, hesitant place matter drifting, gravity slowly negotiating terms, structure forming with caution. That intuition is deeply human. We associate youth with weakness, infancy with vulnerability. But the universe does not share our psychology. What Webb is showing us is that the cosmic dawn was not quiet. It was impatient. To feel why this matters, we need to compress time until it hurts. From the Big Bang to these galaxies is roughly 300 million years. Sounds large until you remember that Earth is 4.5 billion years old, the Sun about the same, and the universe itself nearly 13.8 billion years old. If the universe's entire life were a single calendar year, these galaxies appear within the first 8 days of January, before the weekend, before the rhythm of time had even settled. And yet, stars were already burning in dense populations. Heavy elements were already present. Light was pouring out with enough intensity to cross expanding space and still announce itself to us today. That means star formation wasn't just happening, it was happening efficiently. Gravity, left to itself, is slow. Clouds collapse, gas fragments. Feedback from radiation and explosions usually throttles growth. This is why modern galaxies take billions of years to mature. It's a messy, self-regulating process. But in the early universe, Webb is hinting at a regime where regulation failed. Everything was denser, matter was packed closer together. Dark matter halos the invisible wells that gather gas were forming rapidly and overlapping. When gas fell in, it didn't trickle, it poured. When stars ignited, they didn't politely stabilize their surroundings. They detonated, enriched, collapsed again, and seeded the next generation almost immediately. Think less slow burn, more runaway reaction. And here's where humanity stays in the frame. Every heavy atom in your blood carbon, oxygen, iron requires stars. Not just stars, but stars that live fast and die violently. Supernovae are the universe's foundries, and Webb is showing us that those foundries may have been operating at full capacity almost immediately after the universe became transparent. You exist because something out there refused to wait. Now zoom out slightly. These galaxies aren't just bright. Their brightness is a record. Light doesn't lie about energy output. To glow this much, you need enormous stellar populations. To build those populations so early, you need either more raw material than expected, or a way to turn material into stars with unprecedented speed. Both options are disruptive. If there was more usable matter early on, then our understanding of how matter clumped after the Big Bang is incomplete. If star formation was more efficient, then feedback the braking system of galaxies was weaker or delayed. Either way, the universe's early behavior doesn't match the calm progression we taught ourselves to expect. This is why these observations feel uncomfortable to professionals and intoxicating to everyone else. They crack the sense of inevitability. And uncertainty, handled correctly, doesn't end a story, it invites one. There's another layer to this that Webb quietly reveals these galaxies aren't just large, they're structured. Some show hints of disks, some suggest organized rotation. Structure implies time. Time implies stability. Stability implies that chaos had already burned itself down to something coherent. That's the part that really shouldn't exist. Because chaos is supposed to dominate early, turbulence, random motion, violence without memory. Instead, we're seeing systems that already remember their own formation. If you were there floating impossibly between stars, you wouldn't feel like you'd arrived at the beginning of everything. You'd feel like you'd missed something, like a party that started before the invitation was sent. And now, the uncomfortable question presses closer. If galaxies formed this fast, what else did? Planets need metals. Life needs chemistry. Complexity needs time, but not infinite time. If the universe accelerated its early chapters, then the window for complexity may have opened far earlier than we assumed. This does not mean life was everywhere. It means the conditions that make life possible may have appeared shockingly early. That realization shrinks and elevates us at the same time. We are not special because we are early. We may be special because we are late. And yet, we are here to witness this, to reconstruct a story written in photons that left their sources before Earth had even cooled. James Webb is not rewriting physics. It's reminding us that physics always allowed more than our intuitions did. The equations never promised comfort. We just read them that way. What we're watching now is cosmology doing what it's supposed to do, confront reality, when reality refuses to cooperate. And the universe, characteristically, is not apologizing. As Webb continues to stare deeper using gravitational lenses as cosmic magnifiers, stacking time on time, it is likely we will find even earlier, even brighter structures, not because the universe is trying to shock us, but because it never agreed to be simple. This is not a failure of knowledge, it's the moment knowledge expands. The early universe was not a hesitant sketch, it was a decisive stroke. And somewhere in that violence, that speed, that excess of creation, the conditions for us were set in motion. We are not outside this story, we are downstream of it. And the deeper we look, the more it feels like the universe has always been in a hurry to become something worth looking back at. Speed leaves fingerprints. Not just motion, but consequences, patterns burned into structure that linger long after the rush has passed. When something grows too fast, it doesn't just get bigger, it gets unstable, overheated, prone to extremes. And this is where the universe starts to feel less like a calm expansion and more like an experiment pushed to its limits. Because rapid growth has a cost. Those early galaxies weren't peaceful cities of stars, they were pressure cookers. Gas fell inward at ferocious rates. Star formation surged, then surged again. Radiation blasted outward. Shock waves overlapped. Supernovae didn't politely space themselves apart, they detonated in clusters, carving cavities through their own birth clouds. This kind of environment should self-destruct. That's what makes its survival so provocative. In modern galaxies, feedback rules everything. Too many stars form too quickly, and their radiation heats the gas, preventing further collapse. Supernovae blow material out, growth slows, balance is restored. This regulatory loop is why galaxies like the Milky Way take billions of years to assemble. But Webb is hinting at a time before regulation learned how to assert itself. The early universe was denser by orders of magnitude. Space itself was smaller. Distances that now span millions of light years were once compressed into volumes where gravity could dominate without restraint. Dark matter halos, those invisible frameworks, were stacking rapidly, overlapping, merging, feeding one another. Imagine a city where every building is under construction at once, using shared scaffolding, with no zoning laws, no safety limits, no pauses. That's the early universe Webb is exposing. And yet, from this chaos, order emerged. This is where we feel the scale viscerally. A single one of these galaxies contains billions of stars. Each star is a fusion engine converting mass into energy with relentless precision. Each one is a potential birthplace of planets, chemistry, and future complexity. To assemble that many stars so early requires efficiencies that flirt with theoretical ceilings. The universe didn't just allow it, it exploited it. Now step closer than comfort allows. Picture one of these early galaxies from the inside. The night sky wouldn't be dark, it would be crowded. Stars packed closer together than anything we experience today. Supernovae would be frequent enough to feel routine. Heavy elements would rain into space like ash after a forest fire, seeding the next generation almost immediately. Time between generations would collapse. Where modern star systems take millions of years to recycle material, the early universe may have done it in fractions of that time. Star death feeding star birth in a compressed loop, accelerating chemical evolution beyond expectation. This matters because chemistry is memory. The universe remembers its past through elements. Hydrogen and helium remember the Big Bang. Carbon remembers stars. Iron remembers supernovae. Every heavier atom is a fossil of a specific process under specific conditions. Webb is reading those fossils at the edge of time and finding that the record is thicker than it should be, which forces us into a subtle but powerful shift. The question is no longer, how did galaxies form? It becomes, what did we underestimate about beginnings? Maybe gravity was more decisive early on. Maybe dark matter played a more active role. Maybe star formation physics behaves differently at extreme densities. Or maybe the universe itself transitioned through phases we've only just started to glimpse brief windows where rules bent without breaking. Notice what's happening here. Uncertainty isn't collapsing the story, it's deepening it. And humanity stays inside the frame. Because the same physics that rushed galaxy formation also rushed the production of the elements that would one day make planets solid, atmospheres breathable, and chemistry complex enough to reflect on itself. If the universe sprinted at the beginning, then we're not latecomers to a slow march. We are products of an early explosion of creativity that set the tempo for everything that followed. There is also a quiet emotional inversion here. We tend to find comfort in gradualism, in the idea that complexity requires long patience. Webb suggests something different, that complexity may arise most easily when conditions are extreme, when matter is forced into close proximity, when feedback hasn't yet learned how to say stop. That's not just cosmology, that's a pattern. Pressure creates structure, density creates interaction, interaction creates novelty. The early universe was the most pressured environment imaginable. And now, standing billions of years later, we are detecting the glow of that pressure as it first released itself into form. This isn't about being wrong, it's about being surprised in the right direction. Because Webb doesn't show us a universe that failed to follow laws, it shows us a universe that used them to their fullest, most aggressive extent. The danger would be to assume this was a fluke. But the more Webb observes, the more common these early mature galaxies appear to be. This suggests that what we're seeing isn't an exception, it's a phase, a brief, intense chapter, where cosmic evolution ran hot, fast, and unapologetic. A chapter we had no way to read until now. And that changes the emotional centre of the story. The universe did not hesitate to become complex. It did not wait to become luminous. It did not pause to ensure we'd be comfortable with the timeline. It acted, and from that action came everything else. As we move forward, deeper into the unknown mechanisms that may explain this acceleration dark matter behavior, exotic stellar phases, early feedback suppression, we are not dismantling cosmology. We are watching it grow up, just like those galaxies did. Fast, bright, and far earlier than anyone expected. There is a moment in every investigation where observation stops being passive. You don't just see something, you feel it watching back. That's where we are now. Because these early galaxies don't just glow, they insist. Their light arrives carrying a demand to rethink the conditions you thought were necessary for order. And when something that far away, that ancient, speaks with that much clarity, we don't get to dismiss it as noise. We have to follow the implication wherever it leads. So we follow gravity deeper. In the modern universe, gravity plays a long game. It gathers slowly, patiently. Structures grow over billions of years, nudged into shape by mergers, collisions, and quiet accumulation. But rewind the universe to its earliest epochs, and gravity is operating in a radically different regime. Space is smaller, matter is closer. The same mass produces stronger effects because distances are compressed. Imagine trying to sculpt mountains out of sand versus wet clay. The rules are the same, but the outcome isn't. Early gravity wasn't waiting for permission. It was unavoidable. Dark matter halos were collapsing almost on top of each other. When gas fell in, it didn't drift, it plunged. Cooling processes were faster, densities soared. In that environment, the threshold for star formation wasn't just crossed, it was obliterated. This is how you get runaway behavior. Once the first stars ignited, their radiation didn't gently warm their surroundings. It slammed into dense gas, ionizing it, compressing it, triggering further collapse in neighboring regions. Star formation propagated like a chain reaction. One ignition led to another, then another, until entire regions lit up almost simultaneously. This is not gradualism, this is ignition. And yet, the universe didn't tear itself apart. That's the paradox Webb is forcing us to confront. Because if growth was truly that violent, feedback should have shut it down. Radiation pressure, stellar winds, supernovae, these are supposed to act as brakes. But in the early universe, those brakes may not have worked the same way. Gas was replenished faster than it could be expelled. Gravity was deeper than explosions were disruptive. The fuel supply never ran dry. So the fire kept spreading. Now bring the human scale back in. Every technology you've ever used, every structure you've lived inside, every tool you've touched exists because matter learned how to organize itself efficiently. Cities don't emerge in empty deserts. They emerge where density forces interaction. The early universe was the ultimate high-density environment, and it behaved accordingly. It built fast. This reframes something fundamental. We often imagine complexity as the endpoint of patience. Webb suggests complexity may instead be the natural response to pressure. Given enough density, enough interaction, enough urgency, structure becomes inevitable. The universe wasn't calm enough to stay simple. And that insight ripples forward. Because these early galaxies didn't just produce stars, they produced momentum. Once a system crosses a certain threshold of mass and organization, it becomes self-sustaining. Gravity deepens, gas retention improves, star formation stabilizes into cycles, the chaos transitions into continuity. That means these galaxies weren't just early, they were anchors. They shaped the regions around them, they enriched intergalactic space with metals, they altered radiation backgrounds, they influenced what could form nearby and when. Their existence cascaded forward, affecting everything downstream, including the conditions that would one day allow quieter galaxies like ours to exist. In other words, the universe's early sprint didn't just create anomalies, it set the pace. And now, standing billions of years later, we're catching up to the implications. There is an emotional discomfort in realizing this. It means the universe didn't gently evolve toward us. It erupted past us, leaving us to piece together the aftermath. But there's also something deeply grounding in it. Because despite that speed, despite that violence, the universe remained coherent. Laws held, patterns persisted. From chaos came structures stable enough to last billions of years and eventually, minds capable of noticing them. We are not witnesses by accident, we are consequences. And James Webb is giving us access to the opening act not as a clean diagram, but as a lived environment, a place where extremes weren't rare, they were normal. This is why phrases like shouldn't exist resonate so strongly. They don't mean impossible, they mean uncomfortable. They mark the boundary between expectation and reality, and that boundary is where discovery happens. As Webb continues to collect light from deeper and earlier epochs, it is mapping not just objects, but regimes, conditions under which the universe behaves differently, more aggressively, more creatively than our present-day intuition allows. Each detection stretches the story backward, each confirmation thickens the plot. We are learning that the universe's youth was not a fragile prelude. It was a decisive surge. And that realization quietly reshapes our place in the timeline. We are not late to a slow universe, we are early survivors of a fast one. A universe that did not wait to become interesting. A universe that didn't ask whether it was ready. A universe that began at full intensity and only later learned how to rest. And as we move forward, deeper into this unfolding narrative, one thing becomes unavoidable. If the universe could do this so early, what else did it do before we learned how to look? There's a temptation, when confronted with something this extreme, to reach for comfort. To say we'll smooth this out. To assume the universe will eventually settle back into the shapes we already recognize. But the deeper we go, the clearer it becomes that comfort is not the point. The point is continuity, how one impossible condition flowed into the next without pause, without apology, without waiting for intuition to catch up. Because the early universe didn't just build galaxies fast. It built inevitability. Once these massive early systems existed, the future narrowed, paths closed, options collapsed. Gravity doesn't negotiate, it commits. A galaxy that forms early doesn't just exist, it reshapes its surroundings, pulling matter away from competing structures, starving some regions while supercharging others. Winners emerge, losers fade, the cosmic landscape hardens. This is where the story stops being abstract. Because this is selection, not biological cosmic. Early galaxies acted like gravitational monarchs, claiming territory, setting conditions, deciding where complexity could flourish and where it would never get a chance. Their radiation ionized surrounding gas, heating it, altering how later structures could form. Their supernovae seeded space with metals, permanently changing the chemical future of entire regions. The universe did not grow evenly, it grew unevenly, decisively, and with consequences. If you were to draw a map of the early cosmos, it wouldn't look like a smooth gradient. It would look like a battlefield after the first charge bright. Dominant structures surrounded by regions already shaped by their influence. And those patterns didn't wash out with time. They propagated forward, echoing through billions of years of expansion. This means something unsettling. Our galaxy's story may have been influenced by events that happened long before it existed by early giants that never met us, yet still shape the conditions under which we formed. The Milky Way may be downstream of decisions made in the universe's first few 100 million years. You're not just made of star stuff, you're made of early star stuff. That reframes insignificance. We are small in space, yes. Late in time, yes. But we're deeply entangled with the universe's most extreme phase. The sprint at the beginning still courses through us. James Webb didn't set out to show us that. It just refused to look away. And as observations stack more galaxies, more redshifts, more confirmations the pattern sharpens, these early systems aren't outliers, They are common enough to force a rethink of the baseline. The universe's default mode, at the beginning, may have been maximal effort. Which leads us to an uncomfortable possibility. What if the universe prefers extremity? What if calm, regulated growth, the kind we see now, is not the norm, but the aftermath? A cooling phase. A long exhale after an opening explosion of creativity. This idea flips our emotional orientation. We tend to see ourselves at the peak of complexity, looking back at a simpler past. Webb suggests the past may have been more intense, more productive, more willing to push limits than the present. That doesn't diminish us, it contextualizes us. We live in a universe that has already burned through its wildest phase. What we see now is stability earned through exhaustion. And that realization brings a strange kind of closure, because it means the universe didn't hesitate to become everything it could be. It explored its own parameter space aggressively. It tried extremes early, learned what worked, and carried those results forward. These galaxies that shouldn't exist are not mistakes. They are records of ambition. They are the universe testing how fast it could build, how dense it could pack matter, how brightly it could shine before limits asserted themselves. And the limits did assert themselves, eventually. Star formation slowed, feedback stabilized, expansion diluted density. The cosmos learned restraint, but not before laying down the foundations for everything that followed, including us. This is why the phrase too mature too soon carries such weight. It's not an accusation, it's a revelation. It tells us that our expectations were shaped by a universe that had already calmed down. We mistook the present for the rule, when it may be the exception. Webb is showing us the universe in its most honest phase before equilibrium, before moderation, before the story learned how to pace itself. And as we stand here, billions of years later, reading that story backward in light stretched thin by time, we're not just learning about galaxies. We're learning about beginnings. Beginnings are not gentle, they are decisive. They don't ask whether they're ready. They create readiness by force. The universe began like that, and for a brief, incandescent window, it allowed itself to be more than we ever expected. As we move forward deeper into this narrative, closer to the edge where observation strains and imagination takes over, we're left with a quiet, humbling truth. The universe did not grow into complexity, it exploded into it. And everything we are exists in the long shadow of that first, unstoppable surge. If the early universe exploded into complexity, then what followed was not a reset. It was inheritance. Because once those first massive galaxies ignited, they didn't vanish when conditions changed. They aged, they merged, they collided, they broke apart and reassembled. Their stars lived out full lives. Their black holes grew heavy and patient at their cores. The universe didn't erase its early excess, it folded it forward. This is where time becomes layered. The light Webb captures is ancient, but the consequences of what it reveals are still active. The early sprint didn't end, it slowed into momentum, and momentum, once established, is difficult to stop. Consider what happens when a galaxy forms early and fast. Its gravity deepens quickly. That depth allows it to hold onto gas longer. Holding onto gas means extended star formation. Extended star formation means more metals. More metals mean cooler gas later on, which collapses more easily into planets. A head start compounds. This is cosmic compound interest. Early success multiplies. Galaxies that formed first didn't just exist earlier, they evolved differently. Their central black holes may have grown rapidly, feeding on dense inflows of matter. Their stellar populations aged earlier, meaning by the time the universe reached what we think of as maturity, these systems were already old, already chemically rich, already complex. Some of them may still be out there today, disguised. The massive elliptical galaxies we see in the modern universe, quiet, red, no longer forming stars, may be the descendants of these early overachievers, fossils of a time when the universe ran hot, when efficiency was extreme, when feedback hadn't yet learned to moderate ambition. In that sense, Webb isn't just showing us anomalies, it's showing us ancestry. And ancestry brings the human frame back into focus. Your galaxy is not isolated. It has neighbours. It has a history of mergers. It carries stars older than the sun and atoms forged in explosions long before Earth existed. The Milky Way itself is a palimpsest layers of past events written over one another, but never fully erased. Those early galaxies are part of that story, not directly, but causally. They helped shape the large-scale structure of the universe, the cosmic web of filaments and voids that guides where galaxies can form at all. Dense regions collapsed early. Voids expanded and emptied. Once that structure set in, everything that followed was constrained by it. Freedom narrowed. Possibility channeled. This is why early conditions matter so much, not because they're dramatic, but because they're decisive. And James Webb is revealing that those decisions were made under far more extreme conditions than we ever assumed. There's a psychological shift that comes with realizing this. We often imagine ourselves as products of a long, slow refinement, a universe gradually learning how to make complexity. Webb suggests a different narrative. The universe learned quickly, early, and then spent the rest of its life living with the consequences. That doesn't make us an accident, it makes us an outcome, a delayed echo of an early intensity. And now, something even more unsettling begins to surface. Because if the early universe could assemble galaxies this fast, then the timeline we assign to everything else, black hole growth, chemical enrichment, even the build-up of habitable environments may also need to shift. Supermassive black holes are one of the great puzzles of cosmology. How did they grow so large so quickly? Webb's galaxies suggest an answer. They didn't start from nothing. They were fed by environments where matter was abundant, inflows were relentless, and time between growth spurts was short. Growth once again was efficient. Black holes that form early dominate their surroundings. They regulate star formation. They shape galactic evolution. They become long-lived anchors around which everything else organizes. If those anchors appeared early, then the universe's later calm was built around them. Stability isn't the absence of extremes. It's the long-term effect of having survived them. This reframes the phrase the cosmic dawn. Dawn implies softness, gradual light, gentle emergence. What Webb shows looks more like a detonation. Light everywhere at once, structures forming in parallel, complexity igniting across vast regions almost simultaneously. The universe didn't wake up slowly, it snapped into awareness. And then, having done so, it coasted. Which brings us back to uncertainty, but framed correctly. We don't yet know exactly which mechanisms allowed this acceleration. Dark matter behavior, gas cooling physics, exotic early stars, suppressed feedback, likely not one answer, but several acting together in a narrow window of time. That window is the frontier. Not a wall, an invitation. Because every refinement of our models brings us closer to understanding not just what happened, but why it didn't violate anything fundamental. The laws were always there. The universe simply explored them at their limits. That's not a failure of theory. That's a success of observation. James Webb is doing what the best instruments always do. It's forcing our stories to grow up. And growth, as the universe itself has demonstrated, is rarely comfortable. But it is always consequential. We are living in a universe that began with excess energy, excess density, excess creation. What we experience now is the long settling of that initial abundance into patterns stable enough to last. Stars burn more slowly, galaxies evolve more cautiously, change stretches over eons instead of millions of years. But the memory of that early sprint is still written into the sky. And now, finally into our understanding. We are not late to the universe's story, we are living in its aftermath. A calm surface hiding a violent youth. And as Webb keeps looking deeper, earlier, Closer to the moment when everything was still undecided, it's becoming clear that the universe's most radical decisions were made before we ever had the tools to notice. Until now. There's a quiet danger in calling this an aftermath. It makes it sound like what came later is less important, less alive, less meaningful. But aftermath doesn't mean irrelevant. It means shaped. It means constrained by what survived. And the universe we inhabit, this slower, cooler, more deliberate cosmos, is not a downgrade. It's a consequence that learned how to last. Because speed is not the same as endurance. Those early galaxies burn through their fuel with astonishing efficiency. But efficiency has a shadow. When stars form too fast, they exhaust their reserves. When feedback finally asserts itself, it does so decisively. Many of those early systems likely collapsed into quiet giants, red, old, no longer forming stars long before the universe reached middle age. They won the sprint. They didn't run the marathon. And this is where something deeply human slips into the story. We tend to glorify the explosive beginning, the intensity, the audacity. But life, at least the kind that can reflect on itself, requires something else: stability, time, repetition without catastrophe, a window where change slows enough for complexity to stack instead of reset. The early universe created the ingredients. The later universe created the conditions. That distinction matters. Those galaxies that shouldn't exist didn't host observers. They were too violent, too dense, too unstable. Supernovae were frequent. Radiation levels were extreme. Planetary systems, if they formed at all, would have lived under constant threat. In a strange way, the universe had to calm down before it could be noticed. And that means our existence is not a contradiction to the early sprint, it's its resolution. We are here because the universe eventually learned restraint. But that restraint only makes sense in light of what came before. James Webb is not telling us that the universe was reckless. It's telling us the universe experimented. Early on, everything was allowed. Density was high. Energy was abundant. The cost of failure was low because there was nothing yet to lose. Structures formed and dissolved rapidly. Only the most robust patterns survived. This is not chaos, it's filtering. And filtering produces resilience. By the time the universe cooled enough for long-lived stars, stable planets, and eventually biology, the cosmic environment had already been stress-tested. Violent configurations burned out, fragile arrangements collapsed. What remained was durable enough to persist for billions of years, including the kind of galaxy that can host a quiet spiral arm, a stable star, a small rocky planet, and a species that wonders where it came from. That's not an accident, that's a lineage. And Webb is letting us trace that lineage back to a phase we had only imagined. Notice how the emotional center shifts here. The early universe no longer feels like a threat to our understanding. It feels like a prerequisite. If galaxies hadn't formed so early and so fast, heavy elements would have taken longer to accumulate. If metals were delayed, rocky planets would be rarer. If planets were rarer, chemistry would have fewer chances to explore itself. The sprint made the marathon possible. And this reframes the phrase "shouldn't exist one last time." From our model's perspective, these galaxies are inconvenient. From the universe's perspective, they are foundational. They are not mistakes. They are the scaffolding we forgot to include. Now imagine standing at the edge of one of these early galaxies not as a participant, but as a witness. You watch stars ignite in clusters. You see radiation carve cavities in gas clouds. You feel gravity pulling relentlessly inward. Everything is happening faster than intuition can track. And then, over millions of years, the pace begins to slow. Gas thins, explosions spread material farther apart, expansion stretches space. The firestorm recedes. What's left is mass, structure, memory. That memory propagates forward through time, merging into new galaxies, seeding new regions, setting the stage for quieter eras. The universe doesn't forget its youth, it builds on it. This is why James Webb's discoveries feel so destabilizing and so satisfying at the same time. They don't destroy the story, they deepen it. They tell us the universe didn't gently assemble itself into something capable of being understood. It forced complexity into existence, then allowed it to stabilize. Understanding came later. Understanding always comes later. And now, billions of years after those galaxies first lit up, we are finally equipped to notice them not as points of light, but as actors in a long causal chain that leads directly to us. That realization carries a strange emotional symmetry. We are late, but we are not disconnected. We are small, but we are not irrelevant. We are slow, but we are not behind. We exist at the pace complexity requires, not the pace creation demanded. And the universe, having once sprinted beyond expectation, now stretches into a future where change is slower, but observation is possible. James Webb is our bridge across that divide. It takes the violence of the beginning and translates it into something we can feel without being destroyed by it. It compresses unimaginable scale into images and spectra, and faint signals that still manage to move us. Not because they explain everything, but because they complete something. They remind us that the universe did not hesitate to become vast, structured, and strange. And that somewhere in that early excess, the conditions for us were quietly locked in. The universe ran hard at the start so that one day it could afford to slow down long enough to be seen. When the universe slowed, it didn't forget how to be dangerous. It just learned how to hide it. Because the calm we experience now, the long arcs of stable stars, the predictable rhythms of galaxies is not the absence of violence. It's violence redistributed across time, diluted, stretched thin enough that it no longer overwhelms everything at once. That matters because the same laws that allowed those early galaxies to form too fast are still operating now. They're just working with less fuel, more space, and far more patience. The early universe was dense enough that everything touched everything else. The modern universe is sparse enough that interactions are rare, but when they happen, they still echo that original intensity. Black holes are the clearest example. The supermassive black holes we see today, millions to billions of times the mass of the Sun, are not late inventions. They are ancient. Many of them began growing during that same accelerated epoch Webb is now revealing. They fed early, when matter was plentiful and gravity had no competition. And once a black hole grows large enough, it never truly stops shaping its environment. Even now, in galaxies that appear quiet, their central black holes regulate gas, suppress star formation, and maintain equilibrium. They are fossils of early excess, still exerting control billions of years later. That's inheritance again. Not everything survives unchanged, but nothing is forgotten. This realization changes how we should emotionally read the universe. We often imagine the cosmos as something that gradually cooled into relevance. Webb suggests the opposite relevance was established early, and the rest of time has been about refinement. The first galaxies didn't ask whether they were allowed to exist. They existed, and the universe adjusted around them. That is a very different power dynamic. And it's one that keeps reappearing as Webb looks farther and farther back. Because these galaxies aren't isolated dots. They appear embedded in filaments, early versions of the cosmic web. That web, a vast structure of dark matter and gas stretching across the universe, defines where galaxies can form at all. The web formed early, the nodes ignited early, and once that skeleton was in place, the universe's large-scale shape was effectively locked. Expansion could stretch it. Time could erode details, but the architecture remained. Which means the universe made its biggest structural decisions very quickly. That's unsettling, because we like to believe that the future remains open for a long time. That possibility persists. That complexity emerges slowly and democratically. Webb is showing us that the universe is more decisive than that. Critical moments happen early. After that, everything else plays out inside boundaries already set. This isn't pessimism, it's realism at cosmic scale. and it carries a human echo. In biology, early development matters disproportionately. Small changes in initial conditions cascade forward. Once structures form, later growth refines rather than redefines. The universe appears to behave the same way. Beginnings matter more than middles. Middles matter more than endings. We are living in a middle, and Webb is letting us see the beginning. There's a strange comfort in that, because it means our uncertainty now, the feeling that our models are incomplete, that something fundamental is missing, is not a sign of failure. It's a sign that we are finally asking questions at the right depth. The universe didn't break our theories. It revealed where they were never meant to be final. Those early galaxies aren't contradictions. They are data from a regime we hadn't sampled before. And sampling extreme regimes is how understanding grows. Think about what had to align for this moment to happen. A telescope large enough to collect ancient infrared light, sensitive enough to detect faint signals stretched by cosmic expansion, stable enough to operate beyond Earth's interference, and patient enough to stare for hundreds of hours at patches of sky that look empty to the naked eye. All of that effort, all of that engineering, aimed at answering a single quiet question. How did this begin? And the universe answered not with clarity, but with abundance. Too many stars, too much light, too much structure. An answer that forces us to update not just numbers, but instincts. Because the most dangerous assumption in science is not that we are wrong, it's that we are complete. James Webb is dismantling completeness. It is reminding us that the universe is under no obligation to match the stories we tell about it. Our job is not to force it into shape, but to let its shape reshape us. And that's happening now. With every new detection, every confirmed redshift, every early galaxy that refuses to be small or dim, the universe is quietly asserting a truth we tend to forget. Reality does not wait for understanding. Understanding follows reality. The early universe moved faster than we thought because it could, because nothing constrained it yet, because density and energy allowed it to explore possibilities that no longer exist. What we see today is the aftermath of that exploration, the stable configurations that survived, including us. And that brings us to a final emotional inversion. We are not fragile observers in a hostile universe. We are durable outcomes of a universe that tested itself violently and kept what worked. The same physics that once allowed galaxies to form too early also allowed stars to burn steadily for billions of years. It allowed planets to cool. It allowed chemistry to complexify. It allowed minds to emerge. Extremes made endurance possible. James Webb's discoveries feel shocking because they remind us that the universe did not ease into existence. It arrived with force, it built without hesitation, it settled only after trying everything else. And now, at this moment in cosmic time, we are finally able to look back not to judge that beginning, but to recognize it. Not as a mistake, not as an anomaly, but as the only way this story could have unfolded. The universe was fast so that one day it could be slow, violent so that one day it could be habitable, excessive so that one day it could be enough. And somewhere in that long transition, between sprint and stillness, between ignition and reflection, we appeared late, fragile, temporary, but connected all the same. Not outside the story, inside it, still carried forward by a beginning that refused to wait. By the time we arrive, by the time minds like ours are even possible, the universe has already made most of its irreversible choices. That's a difficult thing to accept. We're used to thinking of the present as the moment of agency, the place where outcomes are decided, but at cosmic scale, agency belongs to the beginning. The opening conditions didn't just start the story, they constrained every chapter that followed. James Webb is letting us feel that constraint for the first time. Because those early galaxies are not just curiosities, they are boundary markers. They tell us where freedom ended and structure began. Once mass concentrated that quickly, once gravity dug those deep wells, the universe's future became channeled. Not predetermined, but narrowed. And narrowing is how complexity survives. A universe where everything remains possible forever is a universe where nothing lasts. Persistence requires limits. The early sprint imposed them. This is why the discovery feels emotionally heavy. It's not just that galaxies formed too early, it's that the universe committed early. And commitment, once made, echoes. Think about how little time there was for hesitation. In the first few 100 million years, matter decided where it would live. Dark matter filaments laid out the map. Gas followed. Stars ignited. Black holes began feeding. Radiation fields rose. Chemistry started accelerating. Those steps didn't wait for equilibrium. They created it. After that, the universe could afford to slow down because the scaffolding was already in place. Which means something subtle but profound. The calm cosmos we inhabit, the one that feels stable enough to be studied, is not the default state. It's the aftermath of a decisive phase that left no room for revision. This doesn't make the universe cruel, it makes it efficient. And efficiency is emotionally ambiguous. On one hand, it diminishes the romance of endless possibility. On the other, it explains why anything persists at all. The universe didn't hesitate because hesitation is expensive. It moved fast when conditions allowed, then locked in what worked. We are standing inside one of those locked-in outcomes. The Milky Way is not inevitable, but it is consistent with early decisions made billions of years before it existed. Our sun is not special, but it formed in a region enriched by earlier generations of stars that themselves trace back to that accelerated epoch. Even Earth's chemistry carries fingerprints of stars that lived and died before galaxies learned how to slow down. You are not just made of ancient matter, you are made of early decisions. James Webb is showing us the receipts. And this is where the phrase "shouldn't exist" quietly dissolves. Because what we're really saying is we didn't think the universe would commit this hard, this early. We mistook restraint for necessity. We mistook patience for law. But the universe had no obligation to grow at a pace that felt reasonable to creatures who would appear billions of years later. It did what physics allowed, not what intuition preferred. That's the deeper correction. And it's one that extends beyond cosmology. We tend to project narratives of gradual improvement, of slow refinement, onto everything. Webb suggests that transformation often happens in bursts. That structure emerges not from balance, but from imbalance that resolves itself by force. This is uncomfortable because it undermines a comforting idea that progress is gentle. Cosmic progress was not gentle, it was decisive. And yet here we are. That's the emotional paradox at the centre of this discovery. The same early excess that feels destabilizing is the reason the universe eventually became quiet enough to host reflection. The sprint created the marathon. The violence made endurance possible. James Webb doesn't threaten our place in the cosmos. It clarifies it. We are not the climax of a slow ascent. We are the long-term consequence of an early surge. And consequences are meaningful. They carry weight. They carry memory. They carry causality forward even when the original conditions are gone. This is why looking deeper doesn't make the universe feel emptier. It makes it feel more connected. The galaxies Webb sees at the edge of time are not strangers. They are ancestors, in a broader sense, architects of the environment that would one day allow observers. Not intentional architects, but effective ones. They shape the terrain. And now, finally, we can see that terrain for what it is. Not smooth, not gradual, but carved quickly, deeply, and permanently. As Webb continues to peer farther back, we will likely encounter even more discomfort. Objects that form earlier than expected. Structures that appear too organized, too massive, too luminous. Each one will feel like a challenge. But they are not challenges to reality. They are challenges to restraint. They force us to accept that the universe's most creative phase may be behind us, and that what we experience now is a long, carefully balanced aftermath. That's not a loss. It's a condition that allows stars to burn steadily, that allows planets to cool, that allows chemistry to linger, that allows time to stretch long enough for memory to emerge. That allows us. The universe moved fast so that one day it could move slowly enough to be understood. And James Webb is our proof that understanding, when it finally arrives, does not simplify the story. It completes it, not by closing questions, but by showing us where they truly begin. At a time when the universe didn't hesitate, didn't wait, didn't ask permission. It simply became vast, structured, and luminous, and left us to grow into the consequences. There is a quiet shock in realizing that the universe did not pause to make room for us. It did not slow down in anticipation of observers. It did not arrange itself to be legible. It did not wait until understanding was possible. It moved first. And only later, much later, did conditions soften enough for something like comprehension to arise. That's the emotional pivot James Webb forces on us. Because when we say those early galaxies shouldn't exist, what we're really confronting is a mismatch between timing and expectation. We expected the universe to take its time. Webb shows us it spent that time immediately. The beginning was not an introduction, it was the main event. Everything afterward is adaptation. This reframes the role of science in a subtle way. We often imagine ourselves as uncovering the rules that governed a calm, orderly universe from the start. Instead, we are uncovering how order emerged from an opening phase that was anything but calm. The laws didn't change, their expression did. In the early universe, density amplified everything. Small asymmetries became decisive. Tiny fluctuations ballooned into massive structures. Once those structures existed, they became attractors' funnels that pulled matter, energy, and future possibilities toward them. Think of it as gravity writing in boldface. Later, as expansion diluted density, gravity had to whisper again. Growth slowed, extremes became rarer, but the ink was already dry. The words written early could not be erased, only elaborated. We live inside that elaboration. And there's something humbling about that, because it means we're not standing at the edge of an unfinished story. We're standing inside a story whose outline was drawn before stars like the sun even existed. Our role is not to influence that outline, but to read it, feel it, and understand how it carried us here. James Webb is not showing us chaos, it's showing us commitment. The universe committed to structure early, committed to complexity early, committed to asymmetry early. That commitment made the future legible. And here's the strange comfort in that realization: the universe didn't hesitate because it didn't need to. There was no risk of meaning being lost, because meaning emerges downstream of structure, not upstream of intention. The universe didn't know we were coming. It didn't need to. It only needed to build conditions robust enough that something could arrive eventually. And it did. But this also places a limit on romanticism. We cannot pretend that the universe is endlessly creative in the way it once was. That phase, dense, fast, permissive, is gone. Expansion has stretched everything thin. Star formation rates decline. Galaxies age. Fuel runs out. The universe is not accelerating into complexity anymore. It is conserving it. And conservation is a different kind of beauty. It's quieter, it's slower, it's more fragile. Which means observation becomes precious. We exist in a narrow window late enough that the universe has cooled and stabilized, but early enough that stars still burn, galaxies still form, and light still reaches us from the beginning. That window will not last forever. One day, the sky will grow darker, galaxies will slip beyond reach. The evidence of that early sprint will fade from view, even if it never truly disappears. James Webb is operating in a rare moment cosmic adolescence where memory is still accessible. That gives this discovery weight beyond novelty. It is not just about revising timelines or updating models. It is about realizing that the universe's most decisive act happened long before anyone could watch, and that watching them now is a privilege that will not be permanent, which brings the human frame into sharp focus. We are temporary, our tools are temporary, our ability to see this far back is temporary. But the story we are glimpsing is not. Those galaxies burned brightly when the universe was young. Their light has survived 13 billion years of expansion, distortion, and dilution to reach us. It crossed a cosmos that grew colder, emptier, and quieter with every passing moment. That light is not shouting, it is enduring. And endurance is its own form of power. James Webb intercepts that endurance and translates it into something we can feel not just intellectually, but viscerally. We are not just learning that the universe formed galaxies too early. We are feeling the difference between a universe that acts and a universe that reflects. Action came first, reflection came later. And now, improbably, reflection is looking back at action. There is a symmetry there that no equation can fully capture. We are built from the products of an early frenzy, living in the calm that frenzy eventually allowed. We carry atoms forged in environments that no longer exist, governed by conditions the universe can never return to. That doesn't make us spectators at the end of history. It makes us witnesses to its consequences. James Webb is not revealing a flaw in cosmology. It is revealing the tempo of reality. Fast when it could be, slow when it must be. Violent when nothing depended on stability, gentle once stability became valuable. And somewhere in that transition, complexity learned how to last. That is not an accident, that is a story. A story written quickly at the beginning, then stretched across billions of years so that one day it could be read. Not all at once, not cleanly, but enough. Enough to know that the universe did not drift into existence. It surged. And everything we are, every thought, every question, every moment of awe exists because that surge happened before restraint, before moderation, before understanding. The universe went first. We are still catching up. If we strip this down to its rawest implication, it becomes almost uncomfortable in its simplicity. The universe did not optimize for observers. Observers emerged because the universe optimized for structure. James Webb is forcing that realization into focus. Those early galaxies didn't exist so that one day they could be studied. They existed because the physical conditions of the early universe made excess unavoidable. Density demanded collapse. Collapse demanded stars. Stars demanded light. Light demanded structure. No foresight, no intention, just consequence layered on consequence. And yet, here we are reading those consequences backward. That inversion is the quiet miracle. Because what Webb is really showing us is not a violation of expectation, but a reversal of perspective. We assumed the universe matured slowly into something capable of complexity. Webb suggests complexity erupted early, and maturity was something the universe had to grow into afterward. That's a very different emotional shape. It means the universe's youth was not tentative, it was reckless with potential. And that recklessness paid off. The galaxies forming too early, too bright, too massive, they represent a phase when the universe had more energy than restraint, more density than regulation. Every instability was amplified, every advantage was multiplied, every successful configuration propagated forward. Later, when expansion diluted density, the universe inherited those configurations and learned how to preserve them. That inheritance is what we see today. Stable galaxies, long-lived stars, quiet planetary systems, time enough for chemistry to explore itself slowly. But those are refinements, not origins. Origins were loud. This helps resolve an emotional contradiction that often sits beneath discussions of cosmology. We talk about the universe as vast and indifferent, yet also orderly and lawful. Webb reveals how both can be true. Indifference dominates early. When nothing depends on survival, order emerges later, because order is the only thing that can survive long term. That's not design, that's filtering. And filtering is brutal. early galaxies didn't all make it. Many burned out, merged, collapsed, or were torn apart. The ones we see, especially the massive, luminous ones, are survivors of an extreme selection process. They represent configurations that could endure even when the universe was pushing itself to its limits. In that sense, they are not anomalies, they are champions. And champions always look impossible in hindsight. Now consider what this does to our sense of cosmic humility. We often find humility and scale the idea that we are small in a vast universe. Webb offers a different kind of humility, temporal humility. The recognition that the most important structural decisions were made long before our epoch began. We are not standing at the centre of the story. We are standing on its accumulated outcome. That doesn't diminish us, it grounds us. Because grounding is not about importance, it's about belonging. We belong to a universe that tested itself early and kept what worked. We belong to a cosmos that did not hesitate to become complex, even if it didn't yet have the capacity to understand that complexity. Understanding was always going to be late. And that's okay. In fact, it may be necessary. If observers had emerged too early during that violent phase, they would not have lasted. Stability is a prerequisite for memory. Memory is a prerequisite for meaning. Meaning is a prerequisite for reflection. The universe had to slow down before it could be noticed. James Webb exists because of that slowdown. The telescope itself is a product of calm precision engineering, long-term planning, patient observation. None of that is possible in a universe still sprinting. So when Webb looks back at galaxies that formed too fast, it is not judging them. It is acknowledging them. Acknowledging that without their excess, there would be no quiet later, no observers, no questions. And now, there is another layer emerging, one that Webb is only beginning to hint at. If the early universe formed galaxies this quickly, then there may have been brief windows of physics we've never directly studied, phases where feedback mechanisms behaved differently, where radiation interacted with matter in regimes we can only approximate, where dark matter may have played a more active, structural role than it does now. These are not breaks in physics, and they are corners of it. Places the universe explored briefly, then moved on from. And James Webb is the first tool capable of reaching back into those corners. That makes this moment rare. Not because we are discovering something shocking, but because we are discovering something irretrievable. These conditions will never exist again. Expansion ensures that the universe has changed permanently, which means every photon Webb collects from that era is a non-renewable resource, a message from a phase of reality that cannot be recreated, only remembered. That gives this discovery a quiet urgency. Not panic, not alarm, just significance. We are not racing against time in a human sense, but in a cosmic sense. We are living during one of the last eras when the universe's beginning is still visible. Future civilizations, if any exist, may inherit a sky where those early galaxies have slipped beyond detection, their light stretched into irrelevance by expansion. For them, the universe's youth will be theoretical in a way it is not for us. We are early enough to see back, late enough to understand what we're seeing. That balance is fragile, and James Webb sits right at its centre. So when we say it found something that shouldn't exist, we're really saying something else. It found something we were not emotionally prepared to integrate. A universe that acts decisively before it explains itself. A cosmos that commits early and lives with the consequences. A beginning that does not wait for comfort. And yet, out of that beginning came a present gentle enough to support curiosity. That is not irony, that is continuity. The universe did not contradict itself, and it matured. And now, improbably, maturity is looking back at youth. Not to correct it, not to tame it, but to recognize it for what it was. The only way this story could ever have started. By now, a pattern should feel unavoidable. Every time we try to soften the universe is beginning to imagine it as cautious, incremental, politely assembling itself, James Webb pulls that comfort away. What it replaces it with is not chaos, but urgency, a sense that the universe did not idle at the start. It acted as if time itself was scarce. And in a way it was because the early universe had something the later universe does not: density. Energy packed tightly enough that interactions were inevitable. Matter could not avoid itself. Gravity did not need persuasion. It simply closed its grip. That condition was temporary. Expansion guaranteed it. So the universe had a window, a brief, incandescent window where everything that could happen would happen faster than at any other time, and that window shaped everything that followed. This reframes beginnings in a way that feels almost unsettlingly intentional, even though there was no intention at all. The universe behaved as if it knew this was its chance. Not because it planned, but because physics, given opportunity, exploits it fully. This is why those early galaxies feel so emotionally charged. They aren't just early versions of familiar things. They belong to a regime that no longer exists, a phase where the rules we see today were already in effect, but operating under conditions that amplified every outcome. Think of it like pressure in the deep ocean, the same water, the same physics, but behaviors emerge that cannot exist at the surface. The early universe was that deep ocean pressure so high that matter behaved in ways we are only now glimpsing. James Webb is our submersible, and what it's revealing is not monsters, but momentum. Once the universe crossed certain thresholds, once stars ignited widely, once galaxies assembled quickly, once black holes began feeding aggressively, there was no rewinding. Expansion could slow processes, but it could not undo them. The universe had committed mass to structure, energy to light, and light to memory. Memory matters. Because light is not just illumination, it is record. Every photon carries information about where it came from, what produced it, what conditions shaped it. When Webb collects that light, it is not just seeing brightness, it is reading a fossil. And those fossils are telling us that the universe did not ease into existence. It declared itself. Now consider how rare this perspective is. For almost all of human history, the universe's beginning was a story we told ourselves. Mythic, symbolic, untouchable. Even when cosmology became scientific. The earliest epochs remained abstract, described by equations, not images. James Webb changed that. For the first time, we are not inferring the early universe solely from theory. We are seeing its consequences directly, seeing galaxies already heavy with stars when the universe was barely old enough to have learned what a galaxy was supposed to be. That visual immediacy changes everything. It collapses emotional distance. It makes the beginning feel real, not as a concept, but as a place. A place that was loud, crowded, and unreasonably productive. And that brings us back to the phrase that started all of this shouldn't exist. There's an honesty in that phrase that formal language avoids. It admits that this discovery doesn't just tweak parameters. It violates expectation at a gut level. It forces a recalibration of what early even means. Early no longer means tentative, early means unleashed. And that has consequences for how we imagine the future. Because if the universe's most creative phase is behind it, if the conditions that allowed explosive complexity are gone, then the future is not about novelty at the same scale. It is about stewardship of what already exists. Stars will continue to form, but more slowly. Galaxies will continue to evolve, but with diminishing fuel. The universe is entering a long era of conservation, not expansion of possibility. And we exist inside that era. That makes our moment strange and precious. We are not living during the universe's birth. We are living during its memory. We are close enough to the beginning to still see it, far enough from it to survive. That balance is rare, which means what James Webb is doing is not just scientific, it's archival. It is preserving access to a phase of reality that will eventually fade beyond reach, even for hypothetical future observers. In that sense, this telescope is less like a microscope and more like a time capsule receiver. It catches messages sent when the universe was young enough to be reckless. And those messages are not apologetic. They do not say, "We were still figuring things out." They say, "This is what happens when everything is possible at once." That realization can feel destabilizing if we cling to the idea that understanding must come first, but the universe has never worked that way. Action precedes explanation, structure precedes interpretation, meaning follows survival. And survival, at cosmic scale, required an early excess that now feels shocking only because we're used to the later calm. We are like adults discovering footage of our own species' infancy, messy, loud, inefficient, yet wildly generative. It feels alien because it no longer reflects who we are now. But it is still us. The universe's early galaxies are not strangers. They are younger versions of a process that continues in quieter form all around us. Every star that forms today is a slowed echo of that first ignition wave. Every galaxy that evolves now does so inside boundaries drawn long ago. James Webb is not undoing the story. It is restoring its opening chapters. And those chapters were never gentle. They were decisive, crowded, and bright beyond expectation. Which means that the universe did not stumble into complexity. It forced its way there. And only later, after exhausting that intensity, did it create the conditions for reflection, for memory, for beings capable of looking back and feeling awe instead of being destroyed by what they see. That is not irony, that is sequence. The universe went first, understanding followed. And now, as we continue deeper into this narrative, closer to the edge where observation strains and inference begins, one truth is becoming impossible to avoid. The universe's greatest act of creation was not making stars. It was making a future quiet enough for those stars to be remembered. And we're standing inside that future, still receiving the light, still piecing together the meaning, still catching up to a beginning that never waited for us. At some point, the shock stops feeling sharp and starts feeling heavy. Not because it fades, but because it settles. By now, the idea that the universe formed massive, mature galaxies far earlier than expected no longer feels like a surprise waiting to be resolved. It feels like a weight that must be carried forward, integrated, lived with. Because once you accept that the universe's opening move was decisive rather than tentative, you can't go back to imagining it as cautious. You can't unknow that it committed early. And commitment changes everything. In human terms, commitment narrows futures. It closes doors. It makes paths irreversible. At cosmic scale, it does the same but across billions of years and unimaginable distances. When those early galaxies formed, they didn't just light up space. They locked in trajectories. Expansion would stretch the universe. Time would age it. But the fundamental layout, the distribution of mass, the placement of deep gravitational wells, the rhythm of star formation was already set into motion. This is why later discoveries don't erase the discomfort Webb introduced. They compound it. Every new early galaxy strengthens the same message: the universe didn't grow up slowly. It grew up fast, then lived with the consequences. And here's where the story subtly turns inward. Because this isn't just about galaxies, it's about how we, as observers, relate to beginnings. We are deeply uncomfortable with beginnings that don't ask permission. We prefer narratives where complexity emerges gradually, where order is earned slowly, where chaos recedes politely. Webb is showing us a universe that did not wait to earn order, it imposed it. That doesn't make the universe arrogant, it makes it honest. Given the conditions, this is what physics does. And the more honestly we look, the clearer it becomes that the early universe was not flirting with possibility, it was exhausting it, trying configurations rapidly, discarding unstable ones, amplifying the survivors. That is not inefficiency, that is optimization under pressure. And pressure, once again, is the key. Everything Webb is revealing traces back to one fact: the early universe was crowded. Matter was unavoidable. Energy density was extreme. The cost of interaction was low, and the payoff was high. In such an environment, moderation is not an option, acceleration is. Which means the early universe was not an anomaly in cosmic history. It was the only moment when such acceleration was even possible. That makes this phase not just early but unique. There will never be another time like it. Expansion has seen to that. And uniqueness brings with it a quiet urgency, not panic, not fear, but awareness. Awareness that we are glimpsing something unrepeatable, something whose evidence is already thinning as the universe continues to stretch and cool. James Webb arrived just in time. Late enough that the universe has stabilized, early enough that its beginnings are still visible. That coincidence is easy to overlook, but it's profound. Because it means our species exists during a fleeting interval when the universe can still show us how it started, and we are capable of understanding what we're seeing. Not perfectly, not completely, but enough. Enough to feel the scale, enough to feel the weight, enough to feel included. And inclusion matters here. The danger of discoveries like this is that they can make humanity feel a race too small, too late, too insignificant. But the opposite is happening. Webb is showing us that the universe didn't build slowly toward us, but it built the conditions that make us possible very early, then maintain them long enough for us to appear. That's not insignificance, that's inheritance. We are not the goal, but we are a consequence that required extraordinary early conditions to exist at all. Those galaxies that shouldn't exist are part of our prehistory not biologically, but cosmically. They helped make the universe chemically rich, structurally stable, and temporally generous. Without them, the later calm might never have arrived. So when we look at them now, we are not looking at mistakes, we are looking at foundations. Foundations are often invisible once the building is complete. They're buried, assumed, taken for granted. Webb is excavating them. And what it finds beneath the surface is not fragility but resolve. The universe resolved itself early, resolved to become structured, resolved to become luminous, resolved to become complex. And once that resolution was in place, everything else could afford to take its time. Stars could burn longer, planets could cool, chemistry could repeat itself enough times to become interesting, life could experiment without being immediately erased. Meaning could wait. That waiting is what we inhabit, which makes our moments strange, balance between two extremes, the violence of the beginning and the emptiness of the far future, too early and nothing lasts, too late and nothing new can form. We exist in between. James Webb's discoveries don't threaten that balance, they explain it. They show us that the universe paid an upfront cost, an intense, accelerated phase of creation, so that it wouldn't have to pay it forever. That cost was paid before anyone was around to complain. And now, billions of years later, we are reading the receipt. Not line by line, not with perfect clarity, but with growing recognition of its significance. The early universe did not hesitate. It did not economize. It did not plan for comfort. It built as much as it could, as fast as it could, while it could. Then it slowed. And that slowing gradual, uneven, irreversible is what makes reflection possible. Which brings us to a quiet but unavoidable truth. The universe did not become understandable by accident. It became understandable because it survived its own beginning. And survival, at cosmic scale, required speed, excess, and decisions made long before understanding existed. We are not here despite that. We are here because of it. James Webb is not asking us to correct the universe. It is asking us to accept its tempo. Fast at the start, slow enough now to be known. And as we move closer to the end of this narrative, that tempo becomes the emotional spine of everything we've seen. The universe went first, hard and fast. We came later, careful and curious. And the connection between those two facts is not a contradiction. It is the story itself, finally coming into focus. By now, the word early has lost its innocence. It no longer means tentative or incomplete. It means decisive, committed, already shaped beyond reversal, and once that sinks in. A deeper realization follows one that doesn't shout, but lingers. The universe did not leave its most important work for later. It did it immediately. What followed was not construction, it was management. That distinction changes how everything feels. Because management is quieter than creation, it's less dramatic, less explosive, but it's also what allows things to last. The early universe built the scaffolding with violence and speed. The later universe learned how to live inside it. We are living inside it now. James Webb is not just showing us galaxies that shouldn't exist, it's showing us that existence itself is something stable, persistent, and intelligible was front-loaded, paid for early, secured before the universe had even cooled. And that realization presses us toward an ending that is not about answers, but about orientation. We need to place ourselves correctly inside this timeline. We are not witnesses to the universe's birth, we are witnesses to its memory. That may sound subtle, but it matters. Memory implies survival. It implies that something endured long enough to be recalled. The light Webb collects is not the light of a beginning still happening, it is the light of a beginning that survived everything that came after it. Expansion tried to erase it, time tried to dilute it, distance tried to bury it. It failed. Those photons crossed 13 billion years and arrived here, now, precise enough to tell us that the universe was already mature when it was barely young. That is not fragility, that is resilience. And resilience reframes scale. We often measure cosmic importance by size or age, but importance can also be measured by persistence, by what manages to remain legible across impossible spans of time. Those early galaxies remain legible, so do their consequences. Every spiral arm we see today, every heavy element in our bodies, every stable star that burns slowly enough to allow planets to exist. All of it traces back to a universe that did not wait to become productive. That productivity feels shocking only because we're used to living in its aftermath. But shock is not the right final emotion. Completion is. Because the story Webb is telling does not end in uncertainty. It ends in alignment. The early universe's speed, the later universe's calm, our moment of observation. They are not separate chapters, they are phases of the same process. A process that began at full intensity, then gradually traded speed for stability, excess for endurance, action for memory. And memory is where we live. This is why the phrase shouldn't exist dissolves at the end of this journey. Not because the mystery vanishes, but because the discomfort finds its place. Those galaxies shouldn't exist according to a universe we imagined as cautious. They exist perfectly naturally in a universe that was once allowed to be extreme. The mistake was never physics, it was temperament. We projected restraint backward, the universe projected urgency forward. And now, finally, the two meet. James Webb is the instrument of that meeting. It stands at a rare intersection, a calm enough cosmos to build precision machines, and a young enough cosmos that its beginning has not yet slipped entirely beyond view. That intersection will not last forever. One day, far in the future, expansion will carry those early galaxies beyond detection, the sky will grow emptier, the story's opening pages will fade into inference alone. But today, they are still visible. Today, we can still feel the scale before fully understanding it. Today, we can still be unsettled and satisfied at the same time. And that is exactly where this story needs to end. Not with certainty, not with closure of knowledge, but with closure of perspective. We're no longer trying to make the universe fit our expectations. We are adjusting our expectations to fit the universe. A universe that did not hesitate. A universe that built fast, burned bright, and then slowed just enough to be remembered. A universe that paid the cost of complexity up front, so that later it could afford meaning. And here we are, small, temporary, late but included. Included because the universe's earliest phase was strong enough to carry its consequences forward for billions of years. Included because the sprint did not collapse into chaos, it resolved into structure. Included because light remembers, James Webb did not find something that breaks the universe. It found something that completes the story of how the universe learned to exist long enough to be known. Fast at the beginning, slow enough at the end, and in between us, looking back, finally ready to accept that the universe never waited to become what it already was. Stand still for a moment right here at the edge of the story and feel what has actually happened. We began with a shock galaxies that should not exist, appearing far too early, far too complete, far too bright for comfort. But shock is only the doorway. What matters is where it leads. It leads here, to the realization that the universe did not slowly become capable of meaning. It created the conditions for meaning immediately, then carried them forward long enough for meaning to wake up. That is the closure. Because the universe's beginning was not a question, it was an answer. An answer to a problem that didn't yet exist, how to turn raw energy into something that could last. The solution was speed. Speed before balance, success before refinement, creation before comprehension. The universe did not hesitate because hesitation would have wasted the only moment when everything was dense enough, hot enough, close enough to touch everything else. That moment passed quickly. Expansion saw to that, and so the universe used it fully, recklessly, decisively, without regard for future observers who might one day feel unsettled by how intense it all was. Those early galaxies are not embarrassments. They are signatures of confidence. They tell us that when the universe had the chance to build, it built hard. When it had access to unlimited interaction, it allowed interaction to run unchecked. When complexity could explode, it did. And then only then did the universe learn how to slow down. That slowing was not weakness, it was preservation. Because endurance requires restraint, and restraint only makes sense after excess has tested the limits. We are living inside that restraint, inside a universe that has already burned through its wildest phase and emerged stable enough to host long-burning stars, quiet planetary orbits, chemistry that repeats instead of resetting, and minds capable of noticing patterns instead of being erased by them. That is not coincidence, that is sequence. James Webb didn't just show us early galaxies, it showed us the price of calm. Calm was earned, paid for with violence, density, and speed at the beginning, and that payment echoes through everything we see now. Every stable orbit, every slow stellar burn, every billion-year-old galaxy that quietly persists. Even the silence of space carries that history. And this is where the emotional resolution locks into place. We are not insignificant because we arrived late. We arrived late because arriving early would have destroyed us. We exist at the only pace that allows reflection, not at the pace that created the universe, but at the pace that allows the universe to be known. That is not lesser, that is necessary. The universe needed to outrun understanding before understanding could exist. And now, here we are receiving light launched before Earth was even possible, decoding it with tools built in a calm that only exists because the universe survived its own beginning. That loop is closed. The beginning creates the conditions create observers, the observers look back. Completion. And yet there is still wonder. Not the anxious wonder of contradiction, but the settled wonder of alignment. Because the galaxies that shouldn't exist no longer feel like errors, they feel like proof. Proof that the universe did not stumble into coherence. It forced coherence into existence, then learned how to keep it. Proof that meaning does not arise from caution, it arises from survival. Proof that reality is not obligated to be gentle at the start, only durable in the long run. James Webb didn't break cosmology. It finished a sentence we'd been reading halfway through. It showed us that the universe's opening move was not fragile. It was decisive enough to echo for 13.8 billion years. And that echo is still reaching us now. Still warming detectors, still bending intuition, still reminding us that we are not standing at the centre of the story, but at a point where the story becomes self-aware. Small, yes. Temporary, yes, but included. Included because the universe's first act was strong enough to carry everything that followed, including curiosity. That is the final scale. Not how big the universe is, not how old it is, but how far its first decisions still reach. They reach into galaxies, into stars, into planets, into bodies, into thoughts. Into this moment. The universe did not wait to become extraordinary. It began that way. And only after surviving that intensity did it slow down enough to be seen, remembered, and shared. That is what James Webb found. Not something that shouldn't exist, but the reason anything ever could. And as we stand here, at the end of this journey, one truth feels complete enough to carry forward. We are not late to a quiet universe. We are early witnesses to a universe that once moved faster than meaning, and slowed just enough for meaning to finally arrive.